We are fleeting travelers on a small cosmic rock called Earth, orbiting an average star we call the Sun, a relatively young remnant of stellar birth that occurred during the last third of the universe's history. When we gaze at the night sky, we are not looking at something eternal, but at a temporary snapshot of a much grander cosmic story. Most of the 100 billion stars scattered across our Milky Way galaxy were born billions of years before the Sun even existed. Compared to them, our presence, our civilizations, our knowledge, our ambitions, are but the faintest spark in an ancient, ever-unfolding universe. It humbles us to realize that in cosmic terms, our record is not very impressive. We are latecomers, standing on the shoreline of an infinite ocean, pretending we already understand its depths. Yet, this realization should not discourage us. It should liberate us. There is a vast expanse of space and time we have never touched, phenomena we have not yet imagined, and mysteries waiting to reveal themselves only to minds willing to see beyond their own boundaries. The most powerful tool we possess is not merely technology or data, but humility, the willingness to admit that we do not know everything. The greatest threat to new knowledge is not ignorance itself, but the arrogance of expertise, the self-assured belief that the world has already been explained, and that new questions are either irrelevant or foolish. When curiosity fades into complacency, science stops being an adventure and becomes dogma. Just yesterday, during a series of interviews with journalists and podcasters, including Gadi Schwartz on NBC News and Elizabeth Vargas on News Nation, I was asked why comet experts are so dismissive of alternative explanations for the strange anomalies associated with the interstellar object 3I/Atlas. My answer drew an analogy between unimaginative scientists and artificial intelligence systems. Both, I said, are limited by the boundaries of their training data. If an AI model is trained only on comet observations, it will insist that every object in the sky must be a comet, regardless of any conflicting evidence. In a similar way, human experts who have spent their lives studying comets often view the universe through that single lens. To them, anything unfamiliar must still fit into the categories they already understand. That is why 1I/Oumuamua, the first known interstellar object to enter our solar system, was hastily labeled a dark comet, even though it displayed none of the typical features of a comet. It accelerated without releasing any detectable gas or dust. Instead of questioning whether it might be something else entirely, scientists clung to the familiar, forcing the data to fit an old model. Ironically, we already know of human-made objects, like 2020 SO, a piece of a NASA rocket booster, or Elon Musk's Tesla Roadster launched by SpaceX, that behave exactly like dark comets because they are technological in origin. Yet, comet specialists routinely ignore such comparisons. Their data set excludes the possibility of technology, and therefore their conclusions must also exclude it. This intellectual rigidity is reinforced by a second, deeply human trait: territoriality. Many experts resist new interpretations not because the evidence is weak, but because acknowledging it would threaten the authority they've built on decades of previous assumptions. Their resistance often manifests as ridicule, defensiveness, or outright hostility toward unconventional ideas. In essence, two forces, the narrow scope of training and the ego's need for validation, combine to create a barrier against discovery. The result is a scientific community that sometimes values comfort over curiosity and reputation over revelation. However, there is a better path forward, one grounded not in ego, but in evidence. The coming weeks leading to the close approach of 3I/Atlas to Earth on December 19, 2025, present an extraordinary opportunity. With modern telescopes and instruments, we can directly measure the composition, density, and velocity of the mysterious jets emerging from this object. We can test whether these jets behave as natural sublimation from icy pockets or as controlled thrust from technological sources. If 3I/Atlas breaks apart during perihelion, scattering fragments like a natural comet, the data will show it. But if the pattern and energy distribution deviate from natural behavior, we must be willing to follow the evidence wherever it leads. Science, after all, is not about defending old narratives. It is about confronting reality with open eyes. This pursuit of truth is not just a scientific process, it is a moral one. When egos dominate, when debates turn into personal battles, and institutions prioritize politics or funding over knowledge, humanity loses sight of its shared curiosity. Social media then amplifies division, turning honest scientific disagreement into tribal warfare. But when we choose humility and wonder instead of pride and cynicism, science becomes a bridge that unites us in awe of the unknown. The universe does not care about our titles or institutions. It rewards only those who listen. A powerful example of how bureaucracy can stifle curiosity occurred recently. On October 2nd to 3rd, 2025, the high-rise camera aboard NASA's Mars Reconnaissance Orbiter captured side images of 3I/Atlas at a resolution of 30 kilometers per pixel, as it passed within 29 million kilometers of Mars. But that data, vital for understanding the object's nature, was withheld for 40 days during a government shutdown. Only after public pressure, including a letter to NASA and a statement from Congresswoman Anna Paulina Luna, who urged NASA to release the data held hostage by politics, did the conversation shift back toward transparency. Her message reminded everyone that scientific discovery should never be a casualty of bureaucracy. Knowledge, especially knowledge that could redefine our place in the cosmos, must not be delayed for administrative convenience. Public fascination with 3I/Atlas has been overwhelming. Even in mundane moments, the curiosity is palpable. After my dishwasher broke down yesterday, I called to order a new one, and the customer service attendant recognized my voice from interviews about 3I/Atlas. She told me she had been following the story online and asked for the latest updates. Such encounters reveal a truth often overlooked by professionals. The public hungers for genuine scientific exploration. People want to feel part of humanity's journey into the unknown, not merely spectators to experts arguing semantics. This shared curiosity is what keeps science alive. As of November 11, 2025, Earth-based observatories can once again focus on 3I/Atlas, now that it has moved far enough from the sun's glare to be visible, more than 30 degrees of angular separation. Over the next several months, we will gather more data, refine our models, and perhaps glimpse the first undeniable signs of something extraordinary. Whether 3I/Atlas turns out to be a natural object or a technological artifact, its story will expand the boundaries of what we know and challenge our assumptions about life beyond Earth. Yesterday, I also placed an official bet with Michael Shermer, the executive director of the Skeptics Society. The terms are simple yet profound. Within 5 years, by December 31st, 2030, there will be indisputable scientific evidence of a technological artifact from an extraterrestrial civilization. The wager is not about money. The proceeds will go to the nonprofit foundation of the Galileo Project, which both Michael and I support. The real stake is intellectual, a test of optimism versus skepticism, imagination versus habit. My statement to the Long Now Foundation, which is officiating the bet, reflects my conviction that the search for extraterrestrial technology is not fringe speculation, but a logical extension of scientific curiosity. The discovery of 3I/Atlas in 2025, the upcoming operations of the Rubin Observatory, and the construction of 3 Galileo Project observatories mark the dawn of a new era. Humanity is no longer waiting passively for radio signals from the stars. We are actively searching for physical evidence, debris, probes, or artifacts, left by civilizations that may have preceded us by billions of years. Statistically, the odds favor the existence of countless Earth-like worlds orbiting sun-like stars throughout the Milky Way. Many of those planetary systems are far older than ours. If even a small fraction of them hosted technological species, their machines or remnants could have crossed interstellar space long ago. Our own Voyager spacecraft, for instance, will exit the Milky Way's disk in less than 1 billion years, a blink of cosmic time. Why assume we are the first or the only ones capable of such journeys? Optimism in this context is not naivete, it is strategy. Life often follows the expectations we set for it. When we believe discovery is possible, we organize our efforts to make it so. The search for extraterrestrial technology then becomes not merely an academic exercise, but a reflection of hope. Hope that intelligence is not a cosmic accident, that we are part of a broader community of minds scattered across the stars. I often say that humanity is on a blind date with interstellar objects. We do not know whom we will meet, but it is worth showing up with an open heart. Perhaps that is the ultimate message of 3I/Atlas and all the debate surrounding it. Beyond the technical measurements and the competing interpretations, what truly matters is our attitude toward the unknown. Are we humble enough to admit that the universe may surprise us? Are we brave enough to challenge the limits of our imagination? The story of 3I/Atlas is not just about comets or spacecraft. It is about the spirit of exploration itself, a reminder that progress depends not on certainty, but on curiosity. As long as we keep asking questions without fear of the answers, we remain true to the essence of science and to the boundless adventure of being alive in this vast and mysterious cosmos.